Again, the relief valve, which sits in the center of this retainer. In other words, let's take a look and see what it looks like here. The relief valve's seat would be pushed in from the bottom, and it's just pressed in there, sealed by an O-ring. There's no fasteners holding it. The relief valve spring, which sits here. And all this is in the middle of that retainer. And the cover sits on top just like that. So that's what that looks like inside that body. Again, here's the cutaway version of it, which you can't see too well, unfortunately. So this is what it's going to look like on all versions, even the larger ones when we get to them. So let's go ahead and talk about the relief valve stems now. Once we get the stems out of the body, there's several things we have to look at. Relief valve seat is obvious, like any compartment. We have to make sure the seat's in good shape. Make sure you check it for if it's good. That's fine. Relief valve spring, our stem assembly, and our cover. Now the cover is sealed by an O-ring. I repeat, the cover is sealed by an O-ring. A lot of times people assume that the diaphragm seals the cover. It's not. It's the O-ring seal. And so what do we know about O-ring seals? Hand tight is all it needs. This particular assembly, the most common misrepair is over-tightening this cover when you put it back together. And we'll talk about that when we put it together. But this is the original relief valve seat that appeared in the 009 series. And this is a 3/4 inch, but up to 2 inch it was a brass stem that looks similar to this. To disassemble it, there was a nut on the top. There was an O-ring on the top, and the O-ring which slid into the cover right there. And on the top of that cover, there was a small little opening hole. It was a breather hole. So what was the function of that breather hole? That's so that when the stem moved up and down, it could breathe, because this upper O-ring was my upper guide, and this piece sticking at the bottom, which went through the center of my relief valve seat right there, was my lower guide. So it was an upper and lower guided stem assembly. And the function of that breather hole is as the stem moved up and down, the air escaped out the top, breathed through there. This particular piece is missing. There's a little brass Schrader valve that sits on top of it, and most of them are missing just like this. It's important to have that open so that it's clear, even if you have to just stick a small pin in there to make sure that it is open, because the stem may not move if it becomes blocked. I've seen people shove screws in there thinking that something was wrong with it. Or if water's leaking out of it, what's wrong is this O-ring right up there. So anyway, back to the stem. You're either going to have a double diaphragm unit or a single diaphragm stem or a rolling diaphragm like this. All three of those versions could be used and have been used over the years. Again, this is the oldest version. There's a lock nut on top. Lock nut comes off. Exposes my upper diaphragm plate, my lower diaphragm plate, my relief valve stem O-ring right here. Then on the bottom, where my relief valve disc is, my guide comes off, and there's a washer, my relief valve disc, and my stem O-ring, which sits right there. Now, we talked about the check disc designs on the 009, where the old version we used to pull the disc out of the holder, then they started making them smaller where it was actually too small to take out like that. The 009 relief valve, and also on the 909 series, the relief valve discs are molded into the disc holder. So when you buy a relief valve disc, you get this entire piece, this brass holder. It does not pull out of that disc retainer. The reasoning is that Watts was having issues with the disc pulling out of that holder as water traveled past it. So to make sure it never came out of the disc holder, they actually molded it right into it. So this is the oldest version. Let's kind of reassemble this. We're going to put our relief valve stem O-ring, our disc washer and guide, like this. There is no O-ring seal on the back, so we don't have to be overly tight. Now, our upper and lower diaphragm washers are important because they're concave, slightly bent to the side. So we've got to make sure when we put it back in, we put our stem O-ring in first, we put the rounded side towards the diaphragm. If you put it where it's facing up like this, you can see the diaphragm goes over it and the stem moves up and down. It's going to cut right on that lip. So the rounded side has to be towards the diaphragm. Upper stem and upper stem diaphragm. Now you'll notice that the hole inside the diaphragm, this piece, were all the same size as this. Notice how much bigger this hole is than the rest of them. Did they cut it wrong? No. These are sized according to that stem. This is sized according to this stem nut. So I want to see this nut here up close, and if you'll notice there's a small little ridge right on the edge right there, okay? And that size of that ridge is what sits in the center of that diaphragm. So that's why that one is a different size, because it has to lock on that lip right there. It's very important to see that lip and make sure you realize it's there when you go to put it back together, because if you just throw this on top and tighten it down, it will not seal. So you actually have to place this second diaphragm over the nut. Once you have it on the nut like that, then you can go ahead and tighten it, making sure it stays centered. Once it's centered, that nut has to be very tight, because you have to have a water seal between those two right there. There's an O-ring on the bottom half here, but if you don't have this nut tight, water will leak right through there. So that has to be very tight. Now, the trouble with the brass stems over the years is, like this, pieces would break off. Just like this one, that guide would be bent to the side a little bit. If you notice how that's just cocked to the side. Think about it. If this has to slide in the middle of that relief valve seat and it's slightly bent to one side, what's that going to do to your relief valve opening point? Obviously, it's going to lower it, because it's not going to come off of that seat. So this was a part that was replaced quite frequently, unfortunately, because it either got bent, or in this case, where it got broken off because somebody over tightened it and literally broke it off inside there. This is another thing about buying repair parts. Watts was very good about selling most common repair parts separately. Yes, you could buy this lower guide by itself, which was relatively inexpensive, instead of having to buy this whole relief valve stem assembly. So that's the brass versions of this. Now, I alluded to earlier that the relief valve cover is sealed by an O-ring. And if you notice how this sits, the two diaphragms, let me take them apart. The large diaphragm, which is actually our diaphragm, is the same diameter as the cover right here. So when that body seals here, that diaphragm's pushing against the body here and against that cover right there. Now the inner diaphragm, if you'll notice, goes right here. This is what separates this O-ring on the top, where the air breathes up and down. So our water seal on that O-ring on that large diaphragm is important, but also why that little washer has to be on that little edge area. Otherwise, the water would leak through there and come out the nut just like that. So back to the premise, though, is that this one sits here, and the larger diaphragm sits just like that. I mentioned earlier that this design caused a few problems with the relief valve opening point. They had some issues getting the relief valve opening point to open reliably above 2 on a regular basis. What would happen is it would open below 2. And some of the reasons were, one is it was put back together. Get this back in here, right? As this was put together, you would be compressing this spring, and as you push the cover on it, notice how that the diaphragm would tend to roll down, like right there. So it would roll in place as you move down on it. It was important to get that diaphragm so it was flat on the body. Now, as you pushed it down and tightened these 4 bolts, yes, it's sealed by an O-ring right there, but by over-tightening that diaphragm, you actually restricted the stemming from moving. In other words, this has to stroke up and down as the demand for the relief valve goes up and down. But if it's being held right here on the edges, it wouldn't allow the stem to travel up and down as easily. So this is a case where when you go to tighten this cover, by over-tightening this cover, you would actually restrict the stem so that the diaphragm couldn't move. Typical scenario would be you go and replace the diaphragm, put it back together, and had an excessively high relief valve opening point, say 5 pounds or 6 pounds, something very high. You take it apart 2 or 3 times, couldn't figure it out. You come back the next day, try it again, and all of a sudden the relief valve point dropped down to 3. Well, that was normal, because what would happen is as the stem moved through its travel, it would stretch the diaphragm out of that holder like that. But if you go ahead and tighten the check covers, remember it's sealed by an O-ring, only requires a quarter turn beyond hand tight, and that'll seal that cover. So if you ever put one back together and you have an excessively high relief valve opening point, loosen the 4 bolts about 1/8 to 1/4 of a turn. What that'll do is loosen the diaphragm so it'll travel its full distance like that back and forth, which will change your relief valve opening point. Now, Watts know they had a lot of concerns with that, so they went to, the next design had a single diaphragm. They also went to a plastic stem. This is a larger size, the 1.5 and 2, but you get the idea. They caught some of the problems were with the dissimilar metals, too. They thought with the brass and the stainless guides like this that they'd have issues where the two metals would bond together, making it so they didn't come apart. So they wanted to go to a plastic construction design, thinking that would help alleviate the problems of the dissimilar metals. They also went to a 4-fingered guide on the bottom instead of the single pin through the center. That way the tolerances didn't have to be as tight. So the lower half came apart like this, the relief valve disc and stem O-ring. Now, relief valve disc, unlike the original version where the disc was put more into a brass holder, this one you'll notice there was a washer in the middle that the disc was molded around it. That helped stabilize the bottom by having it more guided here through that travel through the center of the seat. Notice that it was rounded on the edges so that it could cock sideways if it had to. Because remember, this type of design, the high pressure sensing line comes from the top and pushes down. If the stem cocked sideways for any reason and didn't seal, go straight down along the guide mechanism, it could cock the relief valve, again causing problems on its loading. So by having the more guides on the bottom like this, the 4 instead of just the single pin guide we saw on that one, helped it more stable on the bottom so that it didn't wiggle as much. Then on the top, what they did is they went away from the 2 diaphragm design to the single diaphragm design. The upper diaphragm wasn't actually a diaphragm, but it was an assistant, like a guide on that mechanism. So they went to a single diaphragm, which was a little oversized. And in this way, by having the oversize of the diaphragm, it wasn't able to move, even if it was slightly pinched inside that body. So, diaphragm, plate, and stem. And then this one, same washer sits on the top here as it travels up and down through the cover. Here, stem O-ring, and our guide and washer. That was the second generation of relief valve design. The third generation of relief valve design is what we see here in the M3 version. And I'll take that apart. Because what they went to was a rolling diaphragm, with the concerns of that diaphragm being restricted in its travel. By going to a roller diaphragm like this, it could travel up and down much farther. So it minimized the effect of over-tightening the cover, which caused the relief valve's opening point to be excessively high. So whether it was the double, single, oversized, or the Bellafram design like that, those are the 3 different designs of relief valve stems you were going to see. And in those 3 designs, you were going to see different construction. You were going to see the brass construction, 2 different types of plastic, the black like the Naril or the white plastic type. Whichever version you have, depending which one you had, M2, M3, would be important to have the right designation to make sure you got the right repair parts. Now, as I said, this stem moved through the top, and as it went up and down, it breathed out this hole. So it was critical that that hole was open. It was guided on the bottom through the stem through the seat, and on the top through here. And because the high pressure sensing line brings the pressure from the top, when it went to close, it would push it down this way, which unfortunately caused it to cock sometimes like this. The Watts engineers wanted to find a way that this air hole would not get plugged. So in the M2 version of the 1-inch only right now, they went to a different design. Yes, it looks exactly the same as the larger one here, except for the smaller sign. But instead of having a breather hole in the cover, there is no breather hole. What they did is they put a breather hole through the center of the stem. In other words, if you can see right through that little hole in the center right there, it goes all the way through and comes out the bottom side right there, in the very center there. So as this moves up and down, the breathing action goes through the center of the stem. So when it moves up into the cover, the air is pushed down, and it comes out the bottom through the center of the relief valve seat. So in most of the designs, the air comes out from the cover right here. The 1-inch M2 only, the relief valve cover will not have a hole on it, and the air will come out from the bottom as it moves up and down. So whichever version of the relief valve stem you have, we'll put back the oldest one, which is what I have here. First thing we have to do, our relief valve seat needs to go back into the body. Same thing, with the O-ring, we have to check the bore of where it sits. Cannot overemphasize the point on this design of verifying that the bore where the O-ring sits is there and is clean and not corroded. Because if that spot where the O-ring seals is corroded or damaged and that O-ring can't load itself properly, it will not work. Next thing we want to do is put the check mechanisms in. Okay, so we have our first check like this and our second check like that. Again, check our bore, make sure that's right. We talked about lubricating O-rings properly, how O-rings are lubricated. To remind you again, the lubricant goes between your fingers. You grease the O-ring in a 360-degree fashion and wipe all the way around it. You do not, then you put the O-ring on there. You don't just take this and wipe the grease around the outside. Doing that, the grease will wipe right off. You have to lubricate the entire O-ring. So go ahead and put our first check in, sliding it all the way back into the body. Second check in next. And the test cocks still have to be open. If you have the test cocks closed at this point and try pushing that in there, you're going to actually compress that check inside there. Okay, here's where we're going to pick our retainer, whether you have the plastic or the stainless steel type. This is your way of making sure that those checks are all the way in the body and all the way down. Once I have that ready, now I can take my relief valve spring, which goes on top next. My relief valve stem. Now with this older design, I have to be careful because I have to catch that guide in the center of that stem on the bottom. Notice it is possible, just like that, to go ahead and miss it, didn't I? In other words, I got the cover on okay, but where's my guide? It's protruding out the side of the seat instead of in the very center. So you have to physically get underneath the valve, make sure you have it in the center of the guide just like that. So confirm, just like that, whether it's the single guide or it has the 4 legs on it like the newer designs like this, whichever one you have, that it's in the very center of that relief valve seat. Then once you have the cover on, take your bolts, the 4 bolts, and just tighten them hand tight. This doesn't, again, the O-ring is what's sealing this cover. It is not the diaphragm. And by over-tightening these cover bolts, you're actually causing the check assembly, the check cover to hold that diaphragm. So just get them hand tight, and then all it needs is a small little 8th twist like that. Afterwards, that will be enough to seal that across the cover. You'll notice there's an air bleed on the top of the covers. Use the air bleed. Everybody says, oh yeah, the air will come out through here. No, that's a whole different area on the other side of the diaphragm. Make sure when you pressurize it that you bleed the air out of the diaphragm like this. Now, the test cocks that Watts uses on their assemblies is typical test cocks like we've seen on all the manufacturers with the needle valve, quarter turn ball valve design. But Watts did for a while make a special test cock that looked like this. And what it was, instead of a whole test cock being inserted inside the valve, the test cock would actually have this sticking outside. And what it was a small, like a Schrader valve, like your tire. As you went to put your hose from your test kit over it, it would compress this, which when it compressed it down would open up this small little relief needle valve on the bottom. They still use this on the very small, meaning 1/2 and 1/4 inch sizes on some models, not on the RPs or double checks, but they use it on some of the other assemblies. So if you ever see, instead of a test cock screwed into the body, you see this piece screwed in there just like that. That's what it is. It's a small little push type needle valve test cock. Anyway, so whichever type of relief valve you have, you've got your cover back on. Now it's time to pressurize it slowly. This assembly, more than others, has to be turned on very slowly because your high passage sensing line comes through here, relatively small, low pressure comes in through the body. So just crack that #1 shut off a little bit and let the system go back to a pressurized situation. Bleed the air from the test cocks for the checks, from here for the relief valve. If you have trouble getting it pressurized, you can always run a pressure hose from your #1 test cock to your #2. Use your test hose because you can control a 1/4 inch test cock a lot easier than you can a ball valve, especially if it's a 2-inch ball valve. So that's our 007 double check, which looked like that. Here's our 009 in the 3/4, this being the oldest version. The key thing to remember is to identify that tag very carefully. If you have a tag, make sure if it says M1, M2, or M3, and you'll see on the tag exactly what it says, just like that. Make sure you've got the designation correctly, because if you don't give them that M3 designation right there, you're not going to get the right parts. As you can see between these two bodies right here, here's a 3/4 M3, here's a 3/4 009, quite a bit of difference in body size, so, and a corresponding difference in repair parts. So make sure on the 009 2-inch and under series, cannot overemphasize the point, make sure you have the correct body model designation. Even if it's wrong on the cover like this one, take a look at it, identify the body, and make sure you have the correct one. 2.5 and 3-inch, a little bit different. First of all, the body's made of cast iron and fused epoxy coated, as opposed to the brass we saw in the smaller ones. Here's the 2-piece body design here. You'll see in the 009 series. Single axis cover from the top, relief valve seat on the bottom, just like we saw in the small ones. Everything's identical as we saw in the small ones, just a little bit bigger. First thing we have to do is remove the relief valve sensing line. Obviously my test cocks are missing here, but this brass piece here is part of my high pressure sensing line. There's a small screw right here that holds that into the body as you guide it. And as you get that loose, then you can remove your relief valve cover bolts. Underneath your relief valve cover, just like on the small sizes, there will be a slight spring tension coming from the relief valve. So pull up on the high pressure sensing line. Relief valve cover will have come off just like this. O-ring seal, just like on the small ones. My relief valve stem will come out in one piece, just like that. Relief valve spring. Same type of retainer mechanism as we saw on the small ones. This time you'll see it's a solid stainless steel piece. Comes out just like that. And relief valve seat pushes out from the bottom. So same relief valve seat design, everything we've seen here, just like this. Check assemblies will come out from the top. Here's my first check. Here's my second check. Retainer sits in the middle, just like that. So exact same things we saw in the small design. Again, just a little bit bigger this time. So let's go ahead and look at the relief valve first. Same concern on the upper part of the stem. There is an O-ring, and there's a cover that has the hole in the top where it breathes up and down. Make sure that the hole is open so that the stem will move easily. Relief valve stem has one nut on the bottom. Pull the nut off. Disc holder, stem O-ring. Same relief valve design that is molded into the disc holder. The lower stem comes off but doesn't have to be removed for the average repair. This acts as a guide mechanism through the center of that. The upper portion where the diaphragm is, that same lock nut design, except the whole thing comes off in one piece. It holds the O-ring, our stem O-ring, upper diaphragm plate, lower diaphragm plate, and our relief valve stem. Reassembly is going to be the reverse, same concerns. Make sure the rounded portion is towards the diaphragm as opposed to the sharp portion. Stem O-ring, same thing. The upper part is designed to be the size of the nut, not the size of the stem. So placing it on here, just like that, allows you to get it in place, right like that. Stem assembly and relief valve spring. Check assemblies, similar in design as we saw in the small, just a lot bigger, as I say. So they have that same 8th turn rotation. The easiest way to disassemble these, because the spring is contained, is to place it on something that's stationary, like a piece of rubber or plastic, something that it won't twist. And what that allows you to do is push down on this, pull up, and that'll release your spring tension. Check assembly come off in one piece. One nut holds the disc into the disc holder. Go ahead and change your check disc. Check seat here. Go ahead and change your check disc. The spring does not have to release for the average repair. Reassembling is going to be just the reverse, like that. Putting back together. Same concerns, getting the checks inside the body. I think it's more important to see what they look like inside rather than have them inside, like this. Relief valve through the center, just like that. So that's what it's going to look like with our retainer right through the middle. So let's put it together. Second check goes in first. And very important to make sure the second check is all the way in. You have to look at this here, otherwise the first check will not go in. Then first check next goes in like that. Same story, has to get all the way in past that O-ring, otherwise the retainer won't go in. The relief valve seat on the bottom, right there, just pushes out put the new seat back in if you took it out. Go ahead and install our retainer. Make sure the retainer is holding both checks in the body. Now our relief valve spring goes next, here. And the spring sits right in the center here. Line it up. Now we want to get, the easiest way to do this is to take our relief valve stem assembly in the cover. Helps us line up a little easier. Go ahead and get for the center. Now, a little bit of feel. We want to get our bolts ready before we start pushing down, because the bolts will help us line it up. In other words, sometimes it's hard to get underneath here and look, so you have to line up all your bolts, your relief valve sensing line, and use those as kind of guides, and just kind of move around and you'll see it pop down. Now you look underneath to make sure that the stem is in the center of that relief valve seat, just like that. So use the bolts as your guide to make sure that it's centered. Then go ahead and tighten them down again. And then the relief valve high pressure sensing line, the O-ring here, putting the screw back inside on that. And that's what our 2.5 and 3 inch, this is a 009 version. Obviously it didn't have the relief valve, it would be our double check, would be our 007 version. And that's the construction on the sizes, the small bronze ones and the larger ones, which are the cast iron fused epoxy coated.